So good afternoon, sir. This is my solving for figure P 4.11. This is a beam having supported by a pin at A and a roller at C, and it has a triangular distributed load of 80 kilonewton per meter. So at first we will have to transform the distributed load into a single load, so that we will multiply the 80 kilonewton meter by 1/2, and also the distance, the total distance from A to C. So 1/2 times 80 kilonewton meter times 4 meter is 160 kilonewton. So that we will solve for the reaction at A and reaction at C. So summation of moment at C is equals to 0. Therefore, it is R reaction at A times 4 is for distance times 160 kilonewtons. Since it is a single load, so the focus or the centroid of this load is in the center, in the middle. So that 160 times 2 is equals to 0. So that our the reaction at A is 80 kilonewton. So the summation of forces at Y is equals to 0. So reaction at A positive, then downward of 160 kilonewton minus 160 plus your RC. So that the RC is equals to negative RA plus 160. So since RA is 80, so negative 80 plus 160 is equals to 80 kilonewton. So that to determine the diagram, we have to cut the beam into two segments. So the segment AB and segment BC. So in the segment AB, where X is greater than 0 and less than 2. So this is the cut section. Then this is a distributed load having 80 kilonewton, the reaction at A. So your V is downward, so that this is positive, and a moment of counterclockwise. So the distance of the cut section will be replaced by X, since this is a distributed load, so that the distance in the middle is X times 1/2, that is X over 2. So summation of moment at D is equals to 0. So this is M, positive M, counterclockwise. So M minus 80 times X, 80 times X plus 1/2 of 80 times X over 2. So 80 times X, so makancel lang meter, then i-times man dire sa X over 2 is equals to 0. So M is equals to 80 minus X minus 1/2 80 times X over 2. Therefore, your M is equals to 80X minus 20X squared. Then summation of forces at Y is equals to 0. So 80 minus 80 times 1/2 is 80 over 2 times X. So minus V, downward yung V. So that V is equals to 80 minus 40X. For segment BC, where X is less than 2 and it is greater than 2 and less than 4. So the total distance of the cutted section is 4x. It means the total distance minus the x, that is the total distance from C to E. And then a distributed load of 80 kilonewton meter. The moment is clockwise so that it is positive and V upward. And then moment at E is equal to 0 and clockwise positive. So M plus 1 half times 80. 1 half of 80 times 4 minus x, also times 4 minus x over 2, the distance from the middle to E, and then minus 80, then the distance is 4 minus x is equal to 0. Then M is equal to negative 1 half transpose the other side, 1 half times 80 times 4 minus x times 4 minus x over 2 plus 80 times 4 minus x. Therefore, M is equals to, so 1 half of 80 is negative 40. Negative 1 half times 80 is negative 40 times, divided by 2 also, that is negative 20. Then 4 minus x times 4 minus x, it will be 4 minus x squared plus 80 times 4 minus x. Then expand the 4 minus x squared so that it will be 16 minus 8x plus x squared. Then multiply by negative 20. So negative 20 times 16 is negative 320. So negative 20 times negative 8, that is positive 160. Negative 20 times x squared, negative 20 x squared. Then 80 times 4, that is positive 320. We have negative 320 here, so that it will be cancelled out. So 160x minus 20x squared minus 80x. Then your M, your moment, the bending moment, is equals to negative 20x squared plus 80x. Summation of forces at y is equals to 0. See, so that V is positive, V plus 80 kilonewton minus 80 times 1 half times 4 over x, 4 minus x. 80 times 1 half times 4 minus x is equals to 0. And then transpose to the other side. So it will be positive 80 times 1 half times 4 minus x minus 80. So that 80 times 1 half is 40 times 4, that is 160. So 80 times 1 half is 40 times x, negative 40x. So 160 minus 80 is 80 minus 40x. So we'll have to copy this. And for the shear moment diagram, thanks God. So for the shear force at segment AB, so at segment AB, where x is less than 0, greater than 0 but less than 2, so we will have V is equals to 80 minus 40x. So substituting x to 0, 80 minus 40 times 0, that would be 80 kilonewtons. So this is 80 kilonewtons. And then substituting the x of 2, so that 80 minus 40 times 2, that would be 80 minus 80 is equals to 0. Also for the segment BC, where x is greater than 2 but less than 4, so V is equals to 80 minus 40x. When x is equals to 2, so 80 minus 40 times 2, that would be 80 minus 80 is equals to 0. So it will go down there at 0. And then substituting the x is equals to 4, that would be 80 minus 40 times 4. Then 40 times 4 is negative 40 times 4 is negative 60. So 80 minus 160 is equals to negative 80 kilonewtons. So that is 80 kilonewtons. Negative 80 kilonewtons. Then for the bending moment of segment AB, where x is greater than 0 but less than 2, so the bending moment is 80x minus 20x squared. Substituting the x is equal to 0, then 80 times 0 minus 20 times 0 squared, it will be 0. So it will be here. Then substituting x for 2, so 80 times 2 minus 20 times 2 squared. Then 80 times 2 is 160. Then 2 squared is 4. So 4 times 20, 4 times negative 20 is negative 80. So 160 minus 80, that is 80 kilonewton meter. Segment BC. For the segment BC, where x is greater than 2 and less than 4. So the bending moment is from segment BC is negative 20x squared plus 80x. Substituting the x for 2 is negative 20 times 2 squared plus 80 times 2. That would be negative 80 plus 160. That it gives you an 80 kilonewton meter. So it is here, 80 kilonewton meter. And then for substituting x for 4, that is negative 20 times 4 squared plus 80 times 4, it will gives you negative 20 times, this is 4 squared, this is 16. So negative 20 times 16, that is negative 320. So 80 times 4 is positive 320. Negative 320 plus 320, it will give us 0. So this is 0. So the maximum bending moment, maximum bending moment that is equals to 80 kilonewton meter. And for the maximum shear force, is equals to 80 kilonewton. Thank you.